So I want you to run the deploy scripts so that we have the new version of TerraFlow and hopefully not the error we stumbled upon yesterday. So what we're going to do today, first of all, we're going to go through what we couldn't yesterday, but not the whole of it. Basically, we're going to see the monitoring part, because then we're going to build upon this. So let me show you exactly how it works. So as we saw before, the probe has two parts. So it has a pinger that runs in a mininet host and sends a ping to the server and keeps the latency. And then an agent that, first of all, listens to context for services. So when a service is created, it creates a KPI. And then when latency comes, it sends this KPI value to the database. So this is a schematic of, not real, but how we can define it. So basically, we have, does this open somehow? No, just want to point. I don't. We put that.
No, home.
Ah, okay.
That helps.
Okay, good. Okay, so let's say that we have the blue part is the VM. In the VM, we have instantiated a Docker container, and that Docker container was instantiated when we, basically, it was already instantiated in your VM through the ng SDN tutorial we have. That Docker container runs mininets, and basically Mininet creates these 6 or more correct is to say 3 namespaces. So it creates a namespace for client, it creates a namespace for the switches, and then a namespace for the server. When we say namespace here, it means that these 3 areas, they have different networking capabilities. They have different, for example, here there is a virtual interface that can connect from this namespace to this namespace. But this namespace has different network configuration from this one and from this one. So basically, what we want to eventually do is we want to have an agent that will run here, so in the Docker container area, and then the ping runs in the client. So the pinger has the network configuration of the client, so it can route packets through the topology, and the agent runs in the Docker container, so it can also connect to the VM. Have the deploy scripts completed for all of you? Is somebody waiting?
Yes.
Okay. So nobody is waiting. Okay. So let's go and see how to do that. First of all, as we did yesterday, also, if you open the commands.txt, you can see the various commands we will use. Okay, so it's good to have this open. Again, it's in controller commands.txt. Have you found it all? Okay. So the first section has the commands we need to deploy TerraFlow. We already used that part. And then to run the experiments. We used this yesterday, and we will use it again today. But I want you to go here, to the probe section. And we're using, for now, the old probe. So first of all, what does it mean? So cd controller, so change directory controller, and enter this command here. By this, we are just taking all the environmental variables from TerraFlow in our working environment. Then we're going to go to this directory here, which is the probe directory. And then we're going to run this deploy script. What this does, maybe we should change the name because it doesn't have anything to do with TerraFlow. What this does is just, it copies the necessary files from the VM to the Docker container. That's what it basically does. So, run the deploy.sh. Sorry, what? Which one? Ah, the deployment of TerraFlow. Okay, then wait a bit. You did the source my deploy, right? But before that, you sourced my deploy. Yeah, Control C, stop it. And then source my deploy.sh. This one here. Here. In the command, you have this. Okay, for the rest of you, should I assume that you've run this script here and it successfully copied the files? Yeah, wait a minute, it will just take. You mean about the TerraFlow? You source my. You do these three. You source my deploy, and then here. Sorry, it is wrong here. It should say deploy / all.sh. I'm sorry about this. Sorry about that. Okay, should I? Are you? The rest of you are okay with this one running on the probe directory, the .deploy sh file? Yes.
Mine's still like my deploy is still.
Okay, so you're talking about TerraFlow now, right? Okay, have you sourced my deploy.sh?
Yeah, actually I did it.
Okay. Okay, it shouldn't, if you source my deploy.sh, it shouldn't take long. You guys? Okay. Okay, let's just wait a couple of minutes so that everyone is on the same page. Okay, so. Okay, so now we have connected to Mininet, and if we do ls here, we should get various scripts. You should get less than mine. Basically, you should have TFS agent and TFS ping. This is what we need right now. Okay, so just run, as it also says here, run TFS agent. So line 58. Okay, great. You should get something like this. Now open another terminal and go to controller. And now we're going to go in this command.txt file on the section that says experiment, so on line 9. And we're going to run these commands here. Not all of them until they create the service. Do not delete it. So we should set up, bootstrap, and create service. Were you able to run it? until here, until we run create service. Yes? Okay, so for some of you, you should get here. I did not get it. I'm not sure why. But most of you have this KPI ID, right? Chiara, you have it. You also have it. You have it. No, you have it. Do you guys get it? This KPI ID? Okay, great. I don't have it. I don't know why. It's the same error from yesterday. So now, let's open another terminal. Okay? And let's go on our commands.txt file. And line 62. You can go there. Change directory of this, and then make mn CLI. You should get the CLI of Mininet now. Okay? And then here you should run this client without the mn. The mn in the front there, it just means that we run this on the Mininet prompt. So run this. This pings, and here you should get read. If you had registered the KPIs correctly, so you, Chiara, and also you should also see maybe there create KPI ID. Let's now go and see that in Grafana. So are we okay with that? Should I go over it again? You're okay, or should I go? Okay, you guys, you have it working there. Okay, so let's go to the web UI. Again, it's localhost port 8080/web UI. And change context here so that you get this thing. And go to Grafana. Here it should be admin 123 plus. Everyone have this here? Yes. Admin 123 plus. So this is the username and this is the password. Good? Great. Did you guys manage? Yes, yes. Okay. In the Grafana, we go to the plus sign and then import. You should get this screen. Okay. So here we have to enter a JSON to have a dashboard. I have already created such a dashboard. This can be found here in controller, SRC, tests, Hackfest 3, Grafana, only metrics. So you should find this file here. Controller SRC, tests, Hackfest 3, Grafana, only metrics. You have this file, right? Okay. So copy this. It is a big file, but copy it. Copy the contents, I mean. And then you should import it here. So let me go over that again. We have this file, controller, SRC, tests, Hackfest 3, Grafana, only metrics.json. We just copy the contents to this import in Grafana. Are we okay? Good. And we just load it. Import. Again, this happens. Okay. do you see something here, or you see just blank? Blank, right? Okay, in that case, edit, take this code, go back, create another one, push that little pencil here, paste, and you should get something. Yes. If you just get a blank, so it's like this, you should go there that says panel title, edit. There is some SQL code here, copy it, then go back, create a new panel, go to this pencil, and then if you press this refresh dashboard here, okay. The others? Okay, good. So we are at this state, right? Okay, so here on panel title, just press edit. You should get some SQL code here. Copy it. Then go back. Yes? Okay. Here we have this add panel thing. And then we press here add new panel. Then we press this little pencil here. We remove that, and we paste the other code we have copied. And then if we press here the refresh dashboard, it should show you some graph. If you have registered correctly the KPI, it should show you some graph here. Yes? Great. You guys there in the back? Great. So this is how we can see that we have, this is basically what I've showed you yesterday. Again, it doesn't work, but okay. So then we went over how we could enter a policy and all that. We will not go over this today. But what we want to do today is basically try and recreate these two scripts. So instead of having this TFS agent and TFS ping, we want to recreate them in Python. Through that, we want to see how we can use various tools that TerraFlow exposes so that we can communicate with the various components and, in this case, just create a KPI, etc. Before that, we should talk about the protobuf files. So, what are the protobuf files? Protobuf files, as you know, TerraFlow uses gRPC to communicate between the components. gRPC is a protocol like, let's say, REST, but it has a more concrete way of describing the interaction between the components. So this interaction is described in protobuf files, which describes the schema of the messages that one component should send to the other. So if we need to create a script that will communicate with these components, we need to conform to these protobuf files. And also, it's really a good idea when you're building anything for TerraFlow to always have in mind that, okay, how is this defined in the protobuf? I should go and check how the protobuf is defined, and then I will create the message in that way. So let's take a look at them. The protobuf files are in controller proto. So in this directory, you can see that there are many proto files, and in most cases, every component of TerraFlow has one protobuf associated. It could be that, for example, context has context, but also it has context policy. Here you can see. Now let's go and look at context. So just open context proto. Controller proto, context proto. What it shows here, it is, first of all, a list of services that we have that are implemented by the context service. So the context service implements all these calls. So list context IDs, list contexts, get context, set context, etc. And to implement them, it has to take as an input that kind. So for list context IDs, it takes empty, nothing. For get context, it should get as input a context ID. And then returns some other type. So for example, in set topology, you give it a topology and it returns a topology ID. And all these, so what is the context ID, what is the topology, what is not empty, device ID, etc., are defined lower in the file. For example, you have here that event, there is an enumeration, event type, that defines four different types for the event, which is undefined, which is the generic one if you have something special to create. But then the three that we care about: create, update, and remove. So what you saw before, that when we created the service, TFS agent showed you a line that said, I will create this KPI ID. What happened is that it received an event type of create, and it knew that a service was created, so we should create a KPI for that service. We have different kind of things here, and it's really sensible when you're writing something for TerraFlow to always look at the respective protobuf files to make sure that you are correctly writing stuff. So, as I've said before, what we want to do is recreate this agent and pinger. If we look, it is in Rust, but maybe it is good to take a look at this. So the source code for the already the protobuf files. Yes, these, when you have a server that implements a gRPC, that implements different gRPC methods, basically it implements these protobuf files. So if you have a client that wants to communicate with that server, it has to conform to these protobuf files. Are there any other questions about the protobuf files we saw? We're going, in the exercise we were going to do, we're going to see them a lot, but are there any other questions right now? Okay, so let's go over a little bit the source code of the already existing probes. So just go there. Basically, sorry, it's better to do it here. So in SRC tests Hackfest 3, there is probe TFS, SRC. So these are the source code for the two agents, for the agent and the pinger. So let's open, for example, the agent. This is in Rust, but the general idea, I think that you can get it even if you don't know Rust. So let's go over this. Have you all opened this file? Yes? Okay. So, okay, in the beginning it has various imports and definitions. We can skip over them. Basically, it has a main function. So, if you know, in many different languages, there is a main function that runs the program. And then you can see that there is here in line 85, there is T1, which is our first thread. And then in line 155, there is T2, which is our second thread. So basically, this program comprises of two different threads. The first one, what it does, it is the T1 just waits for the pinger to receive the input, and T2, the second thread, what it does is that it registers to context and creates the KPIs. So you can take a look at the structure to see how it is structured. What we want is to recreate this in Python. I have already provided here in new probe some templates. So I have created these threads and the KPI logs. And the idea here is to give you some time and try and see if we can populate these files. So if we can create these agents and this pinger. So first of all, as we said before, the program structure, it has two files, the agent and the ping. Agent comprises of two threads. So thread A listens to context for service events and registers corresponding KPIs. Thread B waits for values from ping and creates KPI values from them. And the pinger just runs a periodic ping and captures the value. So the first step we should do is try and implement the pinger. This is maybe the easier one. I already provided a template here in ping2.py with some instructions on how we can go on. So the first step is to create the ping. We just, for the beginning, do not care about where this runs, if this will run in the client and should ping the server. Just ping 8888, so Google, and print the value, print the latency value. This is the first exercise, let's say, that we want to do. Okay? Then we will implement the second communication with the agent and also implement the agent. So let's just pause for some minutes and you can start working on this. Basically, the template can be found here on controller SRC tests Hackfest 3 new probe ping 2. We also have the solution here. So let's look at the solution of ping 2. Basically, okay, we define here how many times we want to ping. Because we are doing this iteratively, it's better to just ping once. I saw that you put 3, so it's best to just ping once. Because we are going to ping, so it doesn't matter if we ping more. Then, as most of you did, we just want to run a sub-process and check the output, not just the exit status. So here we run ping with this wait here is just if it doesn't, how much time it will wait if it doesn't get a response before it considers that this, I cannot reach it. Then -c, which is how many times we will ping, and just the host name. And then we have this regular expression here so that we can take the specific latency. Okay, this is maybe the most tricky part, but congratulations to everyone that made it until here. So now we got in the response time, we have the latency it will take. And here we have this call process error. So if we call the process and it returns a non-zero exit status, that means that it couldn't ping. So in that case, we do a response time -1, because that means that we couldn't ping. So we say that if we get a value under 0, that means that we don't have a connection. So, okay, you can just, let me check something, yes. And then here, okay, disregard this part here about the loss ratio. We will maybe check this later. Here it also tries to, okay, let's go over this now. So I've said before that the way these two things, so the agent here and the ping here communicate, is through a socket. A socket is just a Linux file that one process writes to it and one process can read from it. So it creates connections. Why use that is because later, if in Docker containers, we can have mounted volumes that are present in the VM, for example. So we can have the agent, instead of running in the container, running in the volume, in the VM, and they can communicate with the client running here through the socket. Okay, this is just some extra. You can use it as is from the solution. Basically, what we do here is that we create that socket, we connect to that socket, and then send the data, which is basically the response time here. Okay? So you can use this solution. It can be found under where previously we had ping2.py, but under solution. Now, let's try and go to the most difficult part, which is the agent.py. So here it is a little more tricky. What we've said before is basically that, what we said before is that basically agent comprises of two threads. One listens and creates the value. One listens to the events and creates the KPIs. So the first step is try to create the thread A, which listens to the context events for server creation. How we're going to do that? Well, I have created this template here that I have already created these two clients that you can use. These are Teraflow objects, and you can use context client to connect to context and monitoring client to connect to monitoring. And basically, with the help of what we discussed before about the protofiles, so we're going to look at context protofile to check what methods exist and how we can call them. We want to be able here on, this is the solution, sorry, spoilers. So here, we want to listen for context service events and differentiate based on the event type. So we saw before the enumeration. If it's 1, it's create. If it's 2, it's update. If it's 3, it's delete. So first of all, let's try and create, we already have this context client here. Let's try and see how we could connect and how we could communicate. Again, to help you, the hint is to check the context protobuf and see what methods exist for service types. So let's open, first of all, the proto file. So under controller, proto, let's find context proto. And here we should try and find something that has to do with events. What? Get service events. This you mean? Sorry? I don't really get what you're trying to say. Here? Here, okay. Yes? Lower? These are the event types. So these are what types of events there are for service. But also we should find the method that we can use to actually listen to these service events. The methods are above this. Here we have, let's say, the objects. Above the objects are the methods. So here we have different kinds of methods. For example, we have context events, or we have topology events. In our case, we want this. We want the get service events. So basically, So basically, we want here, on line, let's say 66, to use this context client and try and call this get service events. Where is it? Get service events. This, as I said before, as input it takes empty, so nothing, but we have to create that nothing. We have to create that empty object and returns some service event. So if you go here, you can see that first of all, we have this empty object from common proto context PB2. And the idea is to use context.client dot some method, in our case, get service events, and call it with a new empty object. So most of you did something really good. One idea was to go and check this file here. So to go and check the context client. This can be found on src context client. But really, this information here does not give us many information. Why? Because what this context client does, is implementing the protobuf. So the information is on the protobus. You can think those things as methods that can be called on the context client. And the objects that you see are the parameters that should be given to that method. So again, let's go to the solution agent. We can see here that what most of you did, events equals context client dot get service events with an empty object. And then, because this is a stream, so here it says stream, it doesn't return a single value, it returns an iterator. So we go over this iterator. So for event in events, we differentiate. We say, first of all, what is a service event? So here we see that the service event has a service ID and an event. And the event is of type event, which has a timestamp and enumeration. So here we say, for that event, let's take the service ID, and then let's take the type, which is event.event.event type. Why is that? Again, look at the protobufs. Service event has an event of type event. And if we look at the event, now it gets a little tricky with all the events. But if we look here on the event object, it has an event type. So if we follow that, basically it gets us this chain, which is event.event.event type. Yes?
This can be generalized to all events if you want to use sort of overall logic of events including the service.
Yes, but on the other hand, the context, I think it has methods for specific events. So it doesn't have, I'm not sure if it has like get global events. Okay. You should get all the events and handle them differently. And then, based on that event type, we differentiate. And we say, if it's 1, then it is the create event. If it is 3, it is the remove event. And we could also say, if it's 2, it is the update event. Are there any questions? Is it understood what we tried to do here? Again, I don't expect you to to find the solution right away, but the purpose of this exercise is to look at this interaction of protobufs, of clients, and how protobufs define the methods and also the structure of the objects. Is it understood this idea? I mean, I don't expect you to tell me now that you know that this event has the event and the event and the event type. This is something that you should read the protobuf to understand, but the information is in the protobuf. Okay? Okay. So now let's have the break now, and we will continue after the break. Okay. So let's continue. So summarizing what we saw in the last exercise, basically. We saw how we can use the clients that are available in TerraFlow to call various gRPC methods with some input, and how to analyze then the return value. So let's go over this a little bit again to make sure that we have a grasp of it. So basically, here we are calling on the context client the getService event. To see how we will call it, we go to the context profile, and we find this getService event. And we see that the input is empty. So we have to create this empty object. And that's why what we do here, basically calling the constructor of empty, which needs no parameter because it's an empty object. And then on the events variable, we will get the return value. What kind of thing is that return value? Again, we follow the context profile, and we see that it is, first of all, a stream. So it is an iterator, not a single value. And it is of kind service event. Okay? So, first of all, we just iterate over this iterator. So we get the single event. And to extract information from this object now, from this event, we have to again check the protofiles. So we have to find this service event here. So, so if you do find Control F, you can see where this is defined, and it is defined here. Okay? So in line 311. So basically, a service event object comprises of two things. First of all, an event object, named event. So it says here that the service event has two fields. The first field is of type event, and it's named event. And this is a little confusing, but bear with me. And the second one is of type service ID, and it's called service ID. Then we have to go a bit inside and see what is service ID. So again, if you search for service ID, you will find its definition here. So in line 255, sorry. And we see here that it has context ID, which again, we have to go and see what is context ID, and the UUID, which again, we have to go and see what is UUID. But the idea is similar. We have this service ID object that has two objects in it. If you maybe it's easier if you think about it in JSON. So in JSON, you have one object, and you can have another JSON object in it, and another JSON object in it, etc. And it goes on. So here in the code, we say that for every event in the events, so in the stream, we go and say that the event service is event dot service ID. This is from the solution. Don't worry, and don't copy it now. Just I'm explaining what we're trying to do here. So in the event service variable, we get this event service ID. Again here, if we go back to the protobufs, we can see that this is defined service event here, service ID. The variable is the same, the name. You see, service ID. The same goes for UUID and for eventually type. For type, we have to go a little bit deeper. So event, we have to go to the event and then to the event type. Okay. So this is how um, we could use the protobuf files to understand the communication with the various services and how we can then extract certain information from it. So you could also copy that in your solution. This is the part that was missing. Basically, this also the if. I'm hiding the below because. Sorry. This it's available there in new probe solution agent.py. Below it is the second, the solution to the second exercise we're going to go now. So, what? Here in this is the file you have. You also have the solution, but this is the file you have. No, you go yes. So here we have the while true. It is here 61, 62. Something is more here. Okay. So basically, you okay. So basically, what we wanted to create before on the previous exercise is that. So call the get service events and then find the type inside it and differentiate, have a switch case or an if case on basically this. Why we're going only 1 and 3? Again, we have to go on the context proto and we can see if we find event. This has the event type enum. 1, it's create, and 3, it's remove. We don't care about update, we don't care about 0. Here we get the event type. The event type could be one of those 4 things. Okay? Basically, from proto files, you can create clients and services that implement this. Yes, this already exists in TerraFlow. In TerraFlow, you have this for every component. You have this component client. So you have monitoring client, context client, etc. Yes. Yes. You then have to implement the server, the business logic, what happens, but yes. Okay, so now that we have basically this, the idea is to try and see what we should do in case of 1, so in case of create. What we should do is basically create a KPI to monitor it, okay? So first of all, we should find the appropriate method that exists in the monitoring protobuf file that looks like it could create a KPI. So should I give you some minutes to look at it? Basically, you want to open monitoring proto file and see what kind of methods we have here. No, but get stream KPI would get something. We want to create a KPI. So that have you found something that looks like set KPI? Yeah. Set KPI is the method we want to use. So we should, after we find the gRPC that looks like it gets the job done, we should try and create the object that it needs to send it. So it's KPI descriptor. The idea here is that we should go and find what KPI descriptor looks like. This has a lot of things here. Okay, so it has a KPI ID of type KPI ID. Okay, it has a string. This is, if we have primitives here, we are happy because we just create a string. Okay, we have a repeat KPI ID, so it is a list. When we see in protobuf files repeated, it means a list. So in JSON terms, it would mean that square brackets. Okay, an array. And then we have this kind of strange. Well, we haven't seen it again. This something dot something else. What this means is that we reference this type in another file. So this device ID, if you search about it in the monitoring proto, you will not find what it means. But if you search on context, you will find what it means. So device ID, if I search here, nothing returns, only this. However, if I go to context proto and I search for, device ID, I see that the device ID is here, is defined here. Okay? So based on that information, I would like you to try and set this KPI. So create this KPI descriptor and try to call from monitoring. Again, I want to inform you that many of these types can be found imported there. So here we have, for example, KPI ID, device ID, service ID, etc. And we see that here we're importing that stuff, KPI ID, for example, KPI value, etc. Also, sorry, I forgot to tell you. You see this set KPI, it requests a KPI descriptor and returns a KPI ID. This is not pretty clear, but what this means is that to actually see it, we should go to the monitoring source, okay? But first of all these fields in protobuf can be none, can be null. They don't have to always have something. They have to have this structure, but the value of this variable could be missing. So here, the intuition says that we are sending a KPI descriptor that has some things in it, and we are taking back a KPI ID. So most probably, we do not know the KPI ID when we are setting it. Let's have some minutes and we will see the solution and discuss it. Okay, great. So most of you have grasped the idea of what we're trying to do. So let's go over the solution. So basically, as we did here, and we called on context the get service events, we're also trying to call now the set KPI. But instead of having an empty here, we're trying to give it a KPI descriptor. And how do we do that? We say that this KPI descriptor we call the constructor of this class, which is the KPI descriptor, and we give it the parameters we know. So basically, these all correspond to these parameters, but most of them are none because we still don't know. We don't know the KPI ID. We will get this from from monitoring, sorry. We don't know the device ID, the endpoint ID, etc. But we know the service ID. Take a look here. The service ID is of type context service ID. And here, if we go to what we have from the service event inside it had a service ID. And that is what we captured here. So event service, event service. So the service ID, how we couple this KPI with the service is that part here. So basically, we are listening for events, and when an event comes that is 1, create, we already have stored the service ID, and in the KPI that we are creating, we are inputting this event service. So we are matching the KPI with the service. Then, as I've said before, on the monitoring part, this set KPI returns a KPI ID. Why is this important? Because later, we want to put values to this KPI. How are we going to put values? Basically, we have to reference the KPI ID we want to put values inside. So we need the KPI ID. So for that reason, the response, first of all, okay, it's printed, but also we keep it. We keep it in this KPI ID so that we know that in our program, we are monitoring this KPI that is referenced, that it is ID'd by this KPI ID. So when we later going to put values in it, we're going to use this KPI ID value. Is it understandable, that one? Yes? The idea is that this set KPI returns us an ID. And this is the ID that identifies the KPI we have created. So when we want to put certain values for that, when we want to monitor certain values, we have to know that, okay, this KPI ID, which is, for example, 1, corresponds to latency, or corresponds to packet loss. So when we get latency, we want to say that, okay, the latency now is 5 milliseconds. To store it on KPI ID 1, which is latency. Okay? Okay. So, okay, this is the socket path. We can go over this. I would say that you can actually copy that part of the solution to the other part. So here it says your input here until here, from line 63 to 75 in the one we are using to experiment. You can copy basically line 62 to 89, which is the solution. Basically, you could also copy all the thread context func here. Disregard what I'm doing. Okay, so now let me also do that. Basically now we have implemented or see the implementation of the first thread. Which is the thread that connects to the context, listens for services, and creates the KPIs. So we said in the beginning that the agent has 2 threads. The first one is what we have seen, and the second one is that waits for values from the ping and creates the KPI values. Okay. So you can take the ping solution, so the ping 2, if I now run, for example, the pig solution, give me a second. Here. Okay. I will explain to you why I did that. Test 3, Hackfest 3, improve solution. Yes. So if you go to the solution and try to run the ping2.py file, you will see something like this. So it will try to ping, and it will respond to the latency, but also it will say no such file or directory. Why is that? Because we have disregarded one thing from the ping and the agent, that is how they communicate. This is the thing we said before about the sockets. I don't want to go over this in detail. The idea, however, is that here we have this socket path where it tries to find a file that it will communicate in. So what we want is to make more or less the same in the agent. So if we look at the agent that I have given you, you see that, first of all, it creates this TMP sock. If it exists, it removes it, and it creates it. And then here on the thread KPI func, it tries to listen to that socket. Okay? So let's say here that we will get some value. Let's try and work on that assumption. That here, inside here on the data connection, on the data variable, we will have the latency we want, the number we want to put in a KPI. Okay? The idea here is all this code here is to create this socket and be able to communicate with the pinger. Okay? And here at the end, in data, we will have the value of latency. Is that clear? Okay. So let's say that here we have a value. How are we going to create this KPI now, this KPI value? This is the next assumption, the next exercise I want you to check. So here we have decoded the data. We have the value, we have it in data. And we want here to create this KPI value and send it to monitoring. Like we did before by creating the KPI, now we want to send the value. Okay? The idea is the same. We just go to the protobufs. We see what could actually be that method we want to call and try and create it. So if we go to monitoring, we have very different RPC methods. Which one do you think that could be the registration of a value? No. Actually, that's why I asked, because the name is not descriptive. But you can actually look at the input of the method to check. Yes? Include. Yes, include. Again, the name is not descriptive. Exactly. The input is KPI. If you look at the other, it is KPI ID or KPI descriptor here. Here we have KPI. So that is a way to know, again, if we don't have descriptive name, this is bad naming, okay? But even then, we can try and extract some knowledge from the protofiles. So let's try and do this exercise here on the file I gave you with the structure. here with KPI ID lock, we have on data the value we want to include. How will we go on and try and build this? There are a couple of strange things here. But more or less, I think that most of you have grasped the way that we can use the protobufs to create objects and use them, those objects on methods, etc. So basically, here is the solution. So what we are doing here is creating this KPI. So here we have create KPI object, and then here we have include KPI. Okay? Yes. Yes. If I'm not mistaken, monitoring has its own database, and it stores there some time series basically. Yes, this is a nice question. The best way now, it's not a good way, but how we do it now is this KPI description. And also there is this KPI sample type. This is an enumeration in monitoring, if I'm not correct. Sampling type. No, it's in KPI sample type. KPI sample types. Yes, there are some predefined types that we can use to do stuff like what you said. So in our case, if you go to the solution, you see that we have put unknown. We don't use that feature. There are, however, some KPI types, so like packets dropped, received, bytes transmitted, that stuff. So if we want, for example, to have latency milliseconds, the best way to actually do it in a way that can be machine understood is to do it here. Define a new KPI sample type and use it, and that would mean something in the project. So let me go back here. So basically, we're creating the KPI object, and then we are including it in monitoring. There are a couple of things that could be different. First of all, let's look at the KPI here. So KPI. It has KPI ID. We already know that. We kept that before when we set the KPI. And then it has context timestamp and KPI value. Let's go first to the KPI value. KPI value is defined here. So in protobuf, what that means is that it says one-off value. So basically what that means is that KPI value has only one child, let's say. Okay? So it is more like that. Okay? It has only one child. But we say that this child could be something of these different things. So it could be an integer, or it could be an unsigned integer, an integer of 64 bits, a float, a string, a boolean. Okay. So to create that, and to create that in a way that we are sure we're including the correct value, we should go here and say that new value KPI value, and this KPI value dot float val. This is a little tricky because we used to reference the child when it matters, but here there are different childs, but we can have only one each time. So we say that this is what we are using, the float value. And the float value is float data. Okay? The second one is timestamp. Timestamp, for example, somebody could do that, or something similar. The problem here is that this time now would return a string. Or maybe an integer, I'm not sure. But here in monitoring proto, we say that, let me get that time down. Where is it? KPI. So we say that this timestamp is referenced in context. So we should go here to find what timestamp is. And here we see that timestamp is a double. So what we do here is that we create a new timestamp, okay? And in that timestamp, we say that the timestamp is now. Why is that? Because here, the timestamp object has a timestamp field. Okay. So, with that, basically, we have, you can find the solution in the solution. I mean, the idea was not to actually build by yourselves, but to look how we would build such a thing. So you can take the solution from the solution folder directory. We have these scripts in Python, okay? Now, let me just take a look at give me a second. Because I also had that problem with context before. So let me check that if I still have this. It says subscribe. Let's hope that I don't have it. Okay. So, so we have the solution in the solution folder. Let me restore that because I'm not sure if I changed something. Also, if you have changed something in the solution folder, it's best to do that. So you can git status to check if you have changed anything in this path. So in this path, in the solution path. And if yes, you can git restore to get the one that is in the repo. So you should, maybe you have left running the probe from previously. If so, end it. So if you have some running probe sending things like that, just end it now. And also the ping, if you have any pings coming from Mininet. And we could try to see if our Python scripts would work. Let's hope that they do. The commands, again, are in the commands.txt file. Under probe, there are two sections, old probe and new probe. The new probe uses the ones under new probe. So here, yes, I will also go to solution. Yes, exactly. Sorry. Yes. This will not work if you do it like this. So do this. So basically, we want to do this. This line here. And if you are in this directory here, in Teraflow controllers RC tests Hackfest 3 new probe solution, if you run Python agent.py, it should say something like this. So awaiting new connection. Yes? What? Sorry. Did somebody run it? Okay. Where are you? Yes, if you run it, what does it say? Have you go to the commands? Sorry, I don't see that. If you go here and take this one, can you copy it? Okay, paste it. And here run the curly thing. Is it here? Yes. Okay. You have deployed or not?
The Teraflow?
Yes.
Yes. It's running, right?
Yeah, it's running. Yeah, sorry. My bad. Controller. And now it should run. Yes. So now we are running the agent. As I've said before, the difference is that we're running the agent on our VM, not on the Docker container. And now we open another terminal in order to go and run the pinger. So again, cd here to the new probe and to solution. And run copy. So these three cd to, you can copy this, but also cd to the solution, and then run the copy.sh file. Okay? The first command can be found on line 68 of the commands.txt. Let me check something. Okay. Yeah, go to the new probe and then go to the solution and run the copy.sh until here, basically, we want. Okay. Okay, now it's copied. So let's go, let's copy that line here, 78. And here we run make mn CLI to get the CLI for Mininet. So you should get this prompt here. If something is running here, please tell me so, because it means that we have the pinger from previously. Okay, are we all in the same page? You guys? Okay. Do you guys need some help? Okay. And here, if we run client, basically what we have here. Sorry, don't run it. Don't run it yet. Why? Because as it is right now, we have we have run the agent, but the agent does what before it can register, before it can include KPIs. It has to register the device in the KPI. Okay? When does it do that? When we create the service. So before trying to send any values, we should go to the controller, kill any service if it exists. If it returns an error, most probably it doesn't exist, so don't worry. We could also do a cleanup here. I mean, we can go in a clean state. So go in the controller and run first the third one, the delete service, and then the cleanup. Most of you have reached it, basically. The solution is simple. Basically, here we have two cases. If we are in try, it means that the ping has successfully completed. So in the response time, we have a value that is the latency. Okay. If it has not succeeded, it means that the response time took -1 as a value. So here we just say that if it is -1, if it is not -1, sorry, we increment a counter of successful pings. And then it's just a matter of calculating the ratio between total minus successful divided by total. And if that we multiply by 100, we get basically the moving loss ratio. Yes. Because we want the loss ratio, not the success ratio. Okay. Basically, that more or less concludes the first interactive session. We could go over the second one in brief. So we still have I think it's at 1 o'clock we will have the break, yeah? Okay. So let's begin the first part for interactive session 2, and we will continue after the lunch. So a little bit, interactive session 2 will be about P4, okay? So before we begin, I would like to present to you a quick P4 tutorial. So let's open first of all the here in Hackfest 3 we have P4, and here we should have this main.p4 file. This is the source code for the P4 program we are using until now. And a P4 program consists of basically four main things. We have in the beginning a definition of the various headers we will use in the program. Then we have a parser that describes how these headers are parsed. Then we have, I will go back, I just want to give you the overall impression. Then we have this control block, as we say it, which describes the various actions and tables that can be done. And finally, we have the deparser, which describes how we can then emit this packet in the wire. So basically, these are the four blocks of a P4 program. So for example, here we have a header. Basically, this is the header of Ethernet. What that describes to us is that an Ethernet header consists of three values. The first 48 bits are the destination address, so the MAC address. The next 48 bit are source address, and the final 16 bit are the Ether type. It is important to note that here that there is a sequence. We begin with the first, and then we follow with the second. It's not the same if we have put Ether type in the beginning, for example. Okay? So that is one thing to taken into account when defining the header. For most protocols that we use in IP, these header files can be extracted from RFCs or even from Wikipedia for most of them. Then we have this parser. Basically, a parser in P4 is a state machine. It always begins in that state start, and it always ends in that accept state. What we describe here is how we, when a packet comes, how we extract the various headers from it. So here, for example, we have in the packet in packet, and we say that, first of all, extract the Ethernet headers, and then based on ether type, so based on that field there, if it is 0x800, which corresponds to the IPv4 code, then transition to parse IPv4. Okay, and then in parse IPv4 we extract the IP header. It's not defined here, but we will see about it. And then we say that we accept it. This is how we define a header, and then how we define a parser. The control block, basically, as you said before, we define the various tables that we can have. So a table mainly consists of a set of keys and a set of actions. The keys are there to show us how we will match this table, and the actions are there to show us what can be done, what will be done in this, if this hits or if this matches. So in that case, for example, we have a layer 2 exact table. We match based on the destination address by exact. We could have other stuff here. For example, we could have longest prefix, or we could have some masks, etc. And then we say that for this table that has this key, we can have two actions, either set egress port or drop. And we also say that the default action is drop. So if we then go on our control plane and do not define any match action here, this will default to drop. So everything will match and will go to drop. And then we can define the various actions that we use here. Actions can be thought of like functions in other programming languages. So basically they have a name, and then they have some parameters, and they have a body. The parameters are, in most cases, they are set by the controller. So for example, here we have this action which says set egress port. It has a parameter that takes a port number. And what it does is that in standard metadata, it enters in egress spec this port number. This standard metadata is really important in P4. It is defined in the P4 specification. However, it is also dependent, some of them are dependent on the specific switch we are running. So, for example, if you are running some ASIC like Barefoot Toffin or something like that, some hardware switch, it could have different standard metadata. Basically, there is a subset that is always the same, but there is a superset that is not always the same. This specific one, the egress spec, defines where the packet should go out of, which port should go out of. So this was also shown, I think, by Yorgos yesterday. This defines the V1 model that we are using in our case. And basically, as I've said before, we have a parser that parses the packet. Then we have different match action pipeline tables. And then we have a deparser. So, first of all, let's take a look at our P4 program. Yes. To see all this that we have described. So this is the main P4. Basically, what we have here is a really simple header definition and parser. We are only defining the Ethernet header, so MAC address destination, MAC destination address and MAC source address, and the Ether type. And then we define a structure that is the parsed header, so what will be eventually parsed, which is just this. If we also had, for example, header IP here, we could say that the eventual possible parsed headers could also be here, IP, for example. Why this is useful because later when you use control blocks, it's easy to define different cases for parsed header. For example, if this is a bit simple, but if we had also UDP and TCP, we could have two different parsed sets, one that is TCP, one that's UDP, and then we have some specific control blocks for the one and some specific control blocks for the other. So it is good to also have these, let's say, intermediate headers. And then, okay, we have this local metadata. This is some stuff that we could also use for ourselves. Then, as we showed before, pretty much the same, the parser. And the ingress pipeline, we have also this set multicast group, which is how we could have multicast. We didn't showcase it, and we won't go over this, but we could also, this is the way that we could also have multicast groups. But basically, we have the drop action and the set address port action. And then we define this L2 exact table, which has, as we showed before, as a key the ingress port, so where the packet came from, and it can you can actually set the egress port, so where it will go out. And the way we do that is we use this apply block, which says apply this table to the packets, to the incoming packets. Then okay, in the parser we usually emit the packet as we want it to be in the wire. So usually, if we are talking about IP networks, it's Ethernet, then IP, all the encapsulation. Okay, so this is the P4 program we were using until now. The idea for this session, and most of it will be after the dinner, is to try and insert some in-band telemetry here. What is in-band telemetry? We have a session after that, probably by Yorgos, who will present the in-band telemetry in more detail. But the general idea is that how we can, for example, previously, we built monitors that were running end-to-end. So we couldn't know all the intermediate steps, what's happening. In-band telemetry is that idea, how we can have information from all the intermediate steps. So we know, for example, the time it took from one switch to the other, or we know how much time it took in the queue inside the switch, etc. So we are providing a simple in-band telemetry. Well, it's not in-band telemetry. I will explain why. But we're providing a primitive, let's say, step towards in-band telemetry. And for that, we were using the IPv4 options header. This is an optional part in the IPv4 protocol that nowadays it's rarely used. It used to be that you could import their information about the hops, the intermediate hops, or some security information that with IP secure it's not relevant anymore. And we're going to basically use that to embed some information from the switches. So what kind of information can we embed in the switches? These are some, there are more, but these are some of the standard metadata that usually switches have. So we have as we saw before, ingress port and egress port. We have the packet length, so the total length of the packet, the ingress global timestamp and egress global timestamp. So basically what that means is that when it came and when it got out, this is in Unix epoch format. We have the multicast group if it is multicasted. So when you multicast a packet, you assign it to a multicast group, which means that it goes to some specific, out of some specific ports. So ports can be in groups, so that doesn't, multicast does not mean flat, does not mean out of every port. And then we have these things that have to do with the queue in the switch. So basically, the timestamp of enqueuing, the depth, the queue depth at the point of enqueuing, and again the timestamp at dequeuing, and the queue depth at dequeuing. What?
You make some things
I think this is.
Yes.
Yes. I think that also there is a time delta that supports exactly what you're saying. Okay. So to see that, we will see it later, but we have to have some programs. Why is that what I'm showing you not in-band telemetry? Because the general architecture of in-band telemetry has this notion of egress and ingress switches. What that means is that the hosts do not see the telemetry. So a host sends a packet into the network, and the first switch it goes through, it is the ingress switch, and it begins the network, the in-band telemetry idea. And the last switch before the host is the egress. So the first switch creates this all the header needed for in-band telemetry, and the last switch removes them, so the host does not see it. In our case, we are not doing that because it is a little more tricky to do that, but we plan to support it in the future. What we are doing is using having the information on the host. So we will have on the client, we will have a program, the sender, that will create this IPv4 option packet, and then as it goes to the switches, it will be populated. And on the receiver side, we will take the result. This is different. The scripts are taken from the ETH Zurich. This is a really nice, if someone is interested in before, this is a really nice GitHub. I suggest to look at it. It has many examples and many exercises and also presentations. So, okay. So, the program, the P4 program we will use is here in Hackfest 3 int. Int is in-band telemetry. The queue depth int basic. The basic, this program basically marks the queue depth when the packet was taken, okay? So let's see how that is defined here. First of all, okay, we have some constant definition here that are defining basically that this value will be this value. So we have some more expressive language, don't care about it. Then we also define some types. So instead of writing all this, you are writing this. So basically we're saying that a MAC address is 48-bit and an IP4 address is 32-bit. And then we're going on to define the headers. So we define, as before, the Ethernet header and also the IPv4 header. You see that we should follow the RFC for all the various fields that exist. And then we also have the options. Again, these are the standard option IPv4 option structure. Then in the int header, which is the part that we care about, we have these three things. So basically we have the ID of the switch, we have the queue depth, and we have the output port. So at the end, using this program, we should know which switches it passed through, the queue depth when enqueued, and the output port where it went out. Of course, this could, this particular is more to show you that we can do this, because the output port and the switch ID, we already know them from the way we structure our services. The queue depth, we don't know it, but because we don't have a lot of traffic, it usually will be 0 or near 0. But we will see, maybe we can have timestamp later and see how we can use that. Then we have some metadata, and you can see the packet that we're using here is comprised of Ethernet, IPv4, IPv4 option, the count, the number of options we can have, and then this list of int headers. Okay? Is this understood until now? Okay. Again, the same follows for the parser. So we begin from the start, we extract the Ethernet type, and then we, based on the type, we parse IPv4, or maybe we could also parse something else. In this case, we parse IPv4. Here we are doing some verifications regarding the options, because this IHL field, if we have options, it usually, if we don't have options, it usually is set to 5. Okay, so if it is not 5, then we can parse the options, and we go on. Then we have this L2 exact table, which is the one that we used before, so nothing new here. But on the egress pipeline now, so here, until now we only used this one. Now we're talking about this one. So after the packet went through the switch and it is ready to leave the switch. So in that pipeline, we do some things that we are able to, so that we are able to have the int. First of all, we add the int header. This, as you can see here, we create the header we defined before. So we say that it is valid, and then we set a switch ID, which is taken as a parameter. This is an action, okay? And then we use the standard metadata. So to get the egress port and get the queue depth. You can see that there are some casts here. The reason that, why is that, is because we are constrained by IPv4 options. IPv4 options have specific, let's say, bits that we can actually use. So as we showed here, queue depth, for example, is 19 bits. But we don't have that much space, so we should make it smaller. This is why IPv4 is constrained. Okay. Eventually, when we want to have full in-band telemetry, we want to have to define our own protocol, so that we are not constrained by any of these options. Actually, if somebody goes over the in-band telemetry specification, one could see many different options, either using the IPv4 options or some options from TCP, or even defining your own protocol. There are some examples there. Then, then we update the IP header length, so that we know IPv4 has in its header, it has the length of the packet. as we have added more values, more bits, this has lengthened. So we have to update this. And then we define the int table. Here, as it is, first of all, considering what I've showed you previously, there are two differences. First of all, there are no keys. And second of all, this default action also has a parameter. What this means, what this table does, is that it always matches. And by default, it calls this add-int header with the parameter of 1. So if we will run, and we will run it late after the break, this P4 program, we will see that the packet will go through the switches, but it will have switch ID 1 everywhere. Because by default, it goes 1. And we don't have, we haven't implemented any P4 services that actually manipulate this table. And then on the, okay, we have to also update the checksum because we did a lot of changes in the packet. In the previously, we didn't care about checksum because we take it as it is. We just change where it goes. Here we are changing the packet itself, and then we are deparsing it together with the int headers. So this is the P4 program we will check when we come back. Are there any questions until now on the structure and how it is and stuff? Okay. Okay. The idea is, first of all, to check the program itself, see how it works, then to see how we can change this part here in order to have a key, and then also in TerraFlow create the service to put the correct switch ID there. Okay? And then the third part is, as I've said before, here we're having the queue depth. This is because we have low traffic, it will be 0. Okay, so we will check to see if we can change this to something more relevant, for example, timestamp. Okay, this we will do after the break. I think we can break now and resume later. Are you okay, Mohammed? Okay, now that we all have a more or less clean state, we run this from the beginning. So, setup, bootstrap, and before running create service, .sh. Before running .sh, make sure if you are deployed, make sure to first source again the TFS environment variables and run the agent, because it could change some IP addresses or ports. So it's always good when you redeploy, if you have any running instances of something that is already connected to TerraFlow instance, close it, source, and run it again. Okay? So if you have redeployed, source the environmental variables, run the agent, and wait. If you had already a deployment, it's okay. And now, if we go and run the second script, the third basically, the create service, we should get here, yes, an event. So we run here, we run here create service, and on the agent that was running, we should get something like that, maybe that. What it says that I've received a new create event because we created the event. This is the context ID I've received, and this is the service ID I've received. I've sent the KPI, the create KPI, and I've received one back. It could be that you have different here. If you have already run the previous without redeploying, you could have two here. I'm not sure. Yeah. You didn't get anything? Did you source the TFS environment variables before running? Okay. So first of all, here, here, delete. You're not running it somewhere. Okay. Here you have probe.
But it was already running, right?
It doesn't seem so. Controller. Okay, and now Python is apply. Now if you create again, you should see here. Okay, so did everyone have this? Are we in the same page? You guys? Okay, you? Great. Okay, so this means that we have created the event. And then, if you go to Mininet, we now run this, where is it? Here, in line 64, without the mn in front. So just client TFS ping. Sorry, and also 10.0.0.2. It says connection refused to me. Does it also say that to you? I think I know why. Okay, I know why. Here, the reason why is that we may have different sockets. So here it says TMP sock, and here it says TMP sock. So it should be the same. And that even is again. Basically, what that means is that I ran a ping, I took the value of latency, but I couldn't connect to the socket. I couldn't connect to the agent. And the same can be seen here because we have not received any connections. Okay? The why of that, I'm not so sure. The why basically means that here there is a sock here. So solution. Okay, I'm not so sure why that happened. I mean, the volume is mounted, but yeah, this was the idea that they could communicate. Now they don't communicate. We'll see why that happens, and we'll come back to that. So basically, this concludes the first session. We also had this version of to see how we could have loss ratio. I think that we can wrap it up now. Basically, how we would do that is what time is it? Let me check. Okay, we can go over this. I mean, okay. So let's go over the agent, the ping here, and try and see. You have already implemented or copied something from the solution that shows how we take the latency, and let's try and think of how we could also take the packet loss. So what we have here is a tool that pings once and gets the latency. In case it doesn't ping, it goes to that exception there, and the response time is -1. So can we think of something to calculate a moving loss ratio average there? I will give you some minutes to think and try to come up with something. Most of you have reached it, basically. The solution is simple. Basically, here we have two cases. If we are in try, it means that the ping has successfully completed. So in the response time, we have a value that is the latency. Okay. If it has not succeeded, it means that the response time took -1 as a value. So here we just say that if it is -1, if it is not -1, sorry, we increment a counter of successful pings. And then it's just a matter of calculating the ratio between total minus successful divided by total. And if that we multiply by 100, we get basically the moving loss ratio. Yes. Because we want the loss ratio, not the success ratio. Okay. Basically, that more or less concludes the first interactive session.